So you take out 5 out of 52 cards. So you know there are 4 suits. And then, so we consider each suit, okay? So how many choices you can have in a strict flush? It depends on how you play the game. Actually, there's some, so you can choose 1, 2, 3, 4, 5 lah. The number sets you can choose 1, 2, 3, 4, 5 2, 3, 4, 5, 6 and then some say that the largest one should be 10 Jack, Lui, King. How do you call this one? You call Q, is it? Jack, Q, King.
Yeah.
How do you call this one? Ace.
King. So like Jack, Queen, King.
Ace. Okay. Some say there are only choices like this one. Okay. Without the choice, Jack, Queen, King, Ace, and 2. It depends on how you play the game. Okay. Let's say let's consider this choice. Okay, this choice. If you just consider this choice, in terms of the number combination, you have only 10 choices. Okay, you can just consider the first number. Okay, 1, 2 up to 10. Then they have 4 suits. So in total, they are 4 times 10, 40 only.
Sir, but 10 Jack, Queen, King, Ace is royal flush, not straight flush.
You mean this one?
No, starting from 10.
10 and then
Jack, Queen, King, Ace. That's a royal flush.
But it did not stay here, or?
Yeah, I did not.
It depends on how you play the game also. For royal flush, that means the largest one, okay? But consider they are not equivalent, okay, in the game. The 10 Jack, 10 Jack, Queen, King, Ace rank higher than 1, 2, 3, 4, 5. Okay. So
Wait.
it really depends on how you play the game. So it doesn't matter actually. Okay. It really depends on how you play the game. Yeah. So you may have 40 choices in a strict flush or more. If you consider Jack, Queen, King, Ace 2, or Queen, King, Ace 2, 3, or King, Ace 2, 3, 4. Okay.
But sir, why are there only 10 choices?
1, 2, 3, 4, 5, 2, 4, 2, 3, 4, 5, 6, up to 10.
Okay.
Okay, so
like there only. Okay.
It really depends on how you play the game. So but for the remaining, okay, it's not that difficult. So 4 of a kind. So this is much more. It may be easier to find it. Okay. First of all, you need to have a 4 cards of the same number. So only you can have 1, 2, 3 up to ace. Sorry, up to king. So that means you have 13 choices for these 4 cards. Okay. But how about this number? So
like after you move the after you remove like 4 cards out of like 52, you have 48 remaining choices. There could be 48. Yeah.
So that should be 13 times 48. Okay. So the number is already much larger than 40. Let me use
Wait, so but don't you do like 13C1 times 4 because they're 4?
No need.
No.
4C1 or what do you mean?
No, 13C1 times 4.
13C1. 13C1, that means it's 13 now. You don't need to.
And then cancel by 4 because they're 4 like cards.
4 like cards.
Yeah. Is it?
What do you mean by 4 like cards?
Like there are 4 of these same cards.
So you mean the same number? So
Yeah.
you have only 13 choices.
Okay.
Either all A's, either all 2, either all 3, either all 4, up to either.
Okay.
You have 13 choices. Okay. So the next one is about the full house. So, but this one is a little bit difficult to find the number of choices than the 4 of a kind, because first of all, what it depends on how you do the question actually. So I can do it in many different ways. Okay, let's say if let's say we choose these 3 card first. Okay, we choose these 3 card first. So we have 13 number choices. Okay, so it can be ace to up to king. Okay, then for each number, so you need to have 3 cards of the same number. But in the 52 cards, there are 4 cards of the same number. That means you are choosing 4 cards. You are choosing 3 cards of the same number from the 4 cards of the same number. So you can use C4, C3. Or actually, this one is 4. Okay, then right now you have chosen these 3 cards. Then you need to choose these 2. But how to choose these 2? Now, after you have choose this number, actually you have 12 numbers left. So you have 12 numbers. And then you need to take out 4 cards of the same number, take out 2 cards of the same number from 4 cards of the same number. So that is C4, C2. Okay. And that's the answer. So the answer should be 3744. Any question for this one?
And
Kim, you can stop me if our answer is not the same. Okay. For next one, for flush, now this one it means 5 cards of the same suit, excluding the first one. Okay, excluding the first one. So you can so let's find out. So let's find out the number of choices of 5 cards of the same suit. So the number of choices of 5 cards of same suit. So you have 4 suits. Okay, so 4 times. You want to have the same same suit. That means you are taking for each suit they have 13 cards. So you take out 5 cards from the 13 cards. So that is 13C5. Then this is the number of choices for 5 cards of the same suit. Okay. Then for number 4, but this number should be equal to number 4. This one the flush plus the strict flush. So it depends on how you play the game. Okay. So the number 1 choices can vary. Okay. But these 2 add up together to be the same. But it really depends on how you play the game. If no question, and then let's go on to the number 5. Number 5 is another more difficult one. Okay. For number 5, for the strict, you need to exclude the choice of the strict flush. And also it depends on how you play the game. Whether you can't, let's say, J, Queen, King, Ace 2 as a choice. But let's say we consider all the choices, including J, Queen, King, Ace, 2, and also Queen, King, Ace, 2, 3, King, Ace, 2, 3, 4, okay? So in terms of the number set, you have 13 choices. That means from A, 2, 3, 4, 5 up to this, okay? You have 13 choices here. Then you fill in the number, okay, by different suit. So for the first number, you have 4 different suits. For second number, you have 4 different suits. Up to the fifth number, you have 4 different suits. So it should be 13 times 4 to the power 5. And then you need to exclude the choices from the strict flush. So what you need to do is minus that number. Then you get this answer. Okay.
Okay.
So then,
Sir,
uh-huh.
Why is it 13 times 4 to the power of 5?
13 is the number set. So there are 13 number sets. Okay, it depends on whether you count this 3 as one number set. So it may be 10 times 10 times 4 to the power 5.
Yeah.
So you consider this 3 as not the choice. Any other questions? No.
No.
If no, then let's go on. For this one, 3 of a kind. The remaining is actually much more difficult. Now 3 of the kind. So let's first choose these 3 cards first. Now 3 of the kind. Let's choose these 3 cards first. So and then there are 13 different numbers you can choose. And then you are taking out 3 cards of the same number from 4 cards of the same number. So that is 4C3. Okay. And then you need to choose these 2. But you need to remind that these 2 should not be the same number. If these 2 have the same number, that means this is a full house. Then how you should choose these 2 cards? So for the first card, you should choose from 52 minus 4 cards. Why we need to minus 4? Because we don't want to have the same number as the first 3 cards. And then for the next card, you should choose another number. So you should 52 minus 8. Okay, that's it. Okay. If no question, let's go on to have a look.
Wait, 52 minus 4 and 52 minus 8. But why minus 8 again?
We exclude the card of the same number as the first 3 and then the 4th one.
Okay.
So we minus 8.
Okay.
Then for next one, 2 pair. So first of all, we need to choose. These 2 have quite similar properties. They are all pair. So we need to choose a. So you may say that, oh, we can for first pair, there are 13 number to choose. For second pair, it has 12 number to choose. Yes, but if you count it like this, you will double count. Let's say if like AA22 or 22AA, they should count as the same choice, okay? So therefore, how you should count this number, you either divide by 2, or you just use 13C2. That means you are choosing 2 numbers from 13 numbers for the 2 pair number. Okay, so after you are choosing these 2 number, then let's go on to have a look at each number. In each number, in each number, there you have two cards of the same number. So you are choosing 2 cards of the same number from 4 cards of the same number. This is first pair. This is second pair. And then at last, you need to choose this card. So you need to choose it from 52 minus 8. That means you are excluding the cards of the with numbers of the first 2 pairs.
Okay.
The next one, let me think if I get some mistake here. Let me see. Yeah, sorry, I need to divide by 2 here. Because choosing 2-9 or 9-2, they have the same choice. Yeah, is it? Let me think about it. Yeah, so I need to divide by 2. But actually, let's do it like for these 2 cards, you can choose a number. You can choose any 2 numbers from 12 numbers. So it's C12-2. And for each 2, for the third card and fourth card, you need to multiple by 10. Well, multiple by 4 because there's 4 suits.
Okay.
If you count it like 52 minus 4 times 52 minus 8, you will double count some. You will double count like 2, 3, and 3, 2. So quite similarly for let's do the 1 pair. So let's have a look at the pair first. So you have 13 number to choose. Okay, let's say 13 times. Then you are choosing 2 cards of the same number from 4 cards of the same number. So you use 4C2. And then for next 3 cards, you need to choose 3 cards. All of them should have the same. Well, all of them should have different numbers. So that means you are choosing 3 numbers out of 12 numbers. But for each card, you have 4 suits.
And 64.
No, times 4 to the power 3.
Yeah, that's 64.
Yeah. Okay. So that's the answer for 1 pair. For the next one, if you really want to find the number, it's so difficult actually. Okay. Oh, sorry, I pressed the wrong button. Then how should we get the for this one for high card? Actually, if you think carefully, this 9 choice, this 9, how do I say, this 9 different combinations are independent to each other, and also they are exclusive and inclusive. They are exhaustive event. Do you know what is meant by exhaustive events?
No.
Exhaustive, that means if let's say if A, B are exhaustive events, that means these two add up together to be the sample size. Sample size. That means they have all the events in the sample size. So how should you do that? For the number 9, given that the first 8 you get it correct, so that means you are choosing 5 cars out of 52 cars. So this one is the number of all choices or number of the sample space. And then for the number 9, you need to minus the number 1, minus the number 2, and up to minus the number 8. Then you can get the number 9. Okay. Any other questions?
No.
I think that you may be able to search the PDF for the probability. Maybe wait me for a while. Probability of in type PDF. Yeah, I think there's some. I think there are some. Yeah, I find. Eh? You can find the file. I think you may be able to search the file, including all these choice, to find the probability. Yeah, I find the file. Right. Let me send you. Okay. Let me show you here. So they give you all the what can I say? All the steps here. So let me send you this file, and then try to see if you can understand this one. So how did I compute the probability getting nothing? That means the high card. So you just use 13C5 minus the remaining. Okay. So you can have a look at this file after the lesson. Okay. If no question, then let's go on to the next topic. So we have mastered the counting problem. I think because if you know how to do these questions, actually you are very good at counting already. Let me open the textbook. Okay, I can't see the textbook. What's the name of the textbook? Hello. Do you remember
What?
the textbook we used last time?
Wait.
Sir, isn't it in the WhatsApp group?
Yes, but I forget which one. Discrete mathematics with application. Let me download it again.
It was like the Susanna or something like that.
Yeah, this one.
Yeah, discrete method application. Yeah.
Then we have mastered the counting power, okay? For the remaining, you learn it or you have a look it by yourself. We may not be talking about the condition probability. I think you should have learned it in the
So does like the exercises in this textbook, like where are the answers? Are the answers in the last page?
oh
Like the exercises in this textbook,
uh
the answers for them are in the last page?
yeah.
Okay.
I'm not sure, but you may have a look. Or you may search online if there are any solution for you for this test book. Or you may check the answer. Yeah, I think here is the answer. Yeah, but only for the odd number questions. Oh, maybe not sure. Yeah, I think here is the solution. So you can check it by yourself. So and then for next one we are going. We may need to go to talk about a little bit about the graph theorem. That actually is in your D1 Decision Mathematics 1. I think some of you are learning this already, right?
Yeah.
So and then, but I'm not sure. I need to have a look at the syllabus again, and then to see what we need for the combination. But for remaining time, let's talk about the number theorem. So for number theorem, we need to use another textbook. But this textbook may be a little bit difficult. I'm not sure. So this one I've also sent you already. So let's have a look at the simplest one first, okay? That you have learned in primary school. So for this divisibility, so you need to understand how we write the symbols. So let's say if D divides A, okay, we write it like this one. So that means 5 divides 10, okay? Not we don't write it like this, okay? If we write like D divides A, that means A is some constant times D, okay? Sorry, some integer times D.
Yeah, the constant could be 0.5.
Okay. Then okay, I think this is so easy, okay? I don't need to repeat it. And then we need to learn some terms, okay? No, so let's do some primary school mathematics, okay? Yeah. So let's say 13 divided by 5, okay? So what you do is 2 and here, okay? 10 and then here is 3, okay? So let's go, what does this term mean? What does this term called? What is this term called?
Remainder.
Yeah, remainder. So what does this term called? The 4 terms here, okay? Fill in the blank, okay? What does 13 mean?
Divisor, dividend.
Yeah, dividend.
The
Okay.
dividend.
I like this one, okay? And then this one, number 2 is
Quotient.
quotient. 5 is
Divisor.
the divisor. Because some of my other students may forget these terms. So I just talk about these terms first. So and then let's have a look. I think this one is so easy, is it?
Yeah.
B divides A and then C divides, if A divides B and then B divides C, then A divides C. So I don't,
Yeah.
but you may mark it down, okay, in your notes. Let's have a look at this one.
So can we write something like this? Like A divides B divides C. Is that possible?
I never seen this kind of. Yeah, so don't write it like that. For examples, the next example for this one, okay. If a, b, dx, and y are integers, I think it's not difficult to understand now. I may just give you some example, okay. Let's say this is 3, okay. You know 3 divides 6. You know 3 divides 9. Then 3 will divide something times a plus something times b. Some integer times 6 plus some integer times 9, okay? This is obvious. I think this one is obvious. So then let's go on to next one. This one, okay? I think this one is not difficult to understand. This one is just one special case for this one. You can substitute x equal to 1, y equal to 1, or x equal to 1 and y equal to -1. Then that's so easy, okay? And then next have a look. The 7 divide 1001. Yes or no?
Yes.
Yeah.
Do you just use your calculator? No? Yes, no?
Yeah.
No.
Okay, you can try it by yourself, and then you know that it divides, so 7 divides 1. Okay. So how can we show the next one? So you can write from the result of 1, you know 1001 should be some integer times 7. Then 1001 plus 4.
Can't we just take the difference between 105 and 101 and show it's like not 7? That means it's not like a multiple of 7.
Yeah, then how you
Okay, that's pretty good.
So then you can say that and 105 are not the not a multiple of 7, or you can do it like that. So assume that 7 divides 105. We use the proof by contradiction, and then we know that from the part 1 7 divides by 1001. So and then we can use the corollary here. D divided by A minus B. So we can say that and then therefore 7 divided by 4. But this is a there is a contradiction. Therefore proof by contradiction. And then 7 does not divide by 105. Something like that. So and then let's go on to the next one. So and about the prime number. So this is how we define the prime number and composite number. Now all integers are either one prime number or composite number. They have no other choices for all integers. Okay, I think I don't need to explain this theory. So next one. So that means every integer greater than 1 is either prime or composite. So there are infinite many prime number, but it may not be easy to prove it. So let's have a look at how amazing is this proof. If I ask you to think about a proof, how will you prove it?
Prove what? Prove a prime number?
There are infinite many prime numbers.
Oh.
So and then let's have a look at the following proof. So by the list of all the prime numbers from the integer. So they assume they are first of all assume there are finite number of prime number. That means n is the number of prime number. And then this is the largest prime number, okay? And then if we multiple all the prime number together, and then plus one, okay, plus one. This number does not divide 2, 3, 5 up to Pn. Okay. This n, the big N does not divide 2, 3 up to Pn. Do you know why?
Why?
You just because there's plus one here. If you divide, let's say if you divide n by 2, okay, you get 3 times 5 up to times Pn plus 1 over 2. The remainder is not an integer.
Okay.
Therefore, it does not divide. This is not a. This is a. N cannot be prime since there is a larger than Pn, because you first assume that Pn is the largest prime number. But right now you find a number that is greater than n is always greater than Pn, but n is also a prime number.
How can you prove that like n is a prime number? What if like the n is like composite? Maybe divisible by 2. You don't know.
Just like what I said before, okay? If you n divide by any prime number in this list, okay? Because you assume there are finite number of prime number. Here is the list of all prime numbers already, okay? All the prime numbers already. If you n divide by any prime number, okay? Then what you get is 2 times 3 times Pn minus 1, okay? That means the prime number that is less than this one. Pn plus 1 is the prime number that is larger than this one, times up to Pn plus 1 over Pn. Then the remainder is not 0. For all the prime, if you divide n by all the prime numbers, all the remainder you get is not 0. That means n is not a composite number. It should be a prime number from your definition, from what we assume.
Okay.
But maybe let's do a easier one first, okay? So let's say, let's assume that there are only 3 prime numbers in the realm, okay? So and then we define number n is 2 times 3 times 5 plus 1. So that should be 31, okay? That should be 31. Then, because 31 is greater than 5, that means it is not in the list of your prime number. Then what does it mean?
Okay.
So n by your assumption is not a prime number. But you can
because there's a 2, so all it's going to be even, and then once you add 1, that becomes like an odd, and the prime number can only be odd. So that's why. isn't it?
No. You maybe Kim, you can explain better, okay?
Explain what you mean.
So do you understand this theorem?
Yeah.
So can you explain it again?
Basically, what part do you not understand?
Yeah, I wonder which part you don't understand.
Like how can we assume that like multiplying all the prime numbers and then adding one will give us prime number?
Now, first of all, you should know that we have a assumption first, okay? We assume there are finite number of prime number.
Yeah.
So here are the list of all prime numbers already.
Okay, yeah, I get that.
Then if you multiple all the prime numbers and then plus 1, this number always is greater than Pn.
Yes.
Then this is by your assumption is not a prime number.
Yeah, we don't know if like the larger number than Pn is a prime number or it's not a prime number.
No, by your assumption, you already assume that Pn is the largest prime number.
Yeah, Pn is the largest prime number.
So
But like
this number is larger than Pn. That means it should be a composite number by your definition.
yeah.
Then we know that n does not divide all the prime numbers in your list,
Yeah.
in your assumption. That means that n should also be a prime number.
Oh, okay.
Which contradicts your assumption.
Oh, okay. I get it now.
So therefore, proof by contradiction, there are infinitely many prime instead of the finite number of prime number. Okay. So this is really a simple and very beautiful proof actually in mathematics. Okay. But I simplified the proof already. So you may have a look here, okay? You may have a look at the textbook. So there another proof. So you may have a look at it later on. So and then we skip the old school part. So let's have a look at another part. So and then you may have a look. You may really need to have a look to appreciate the proof. So let's have a look at next one, the division algorithm. So we just have defined all these terms already, okay? So then, now there exists a unique integer Q and R, so that this, if you want to prove this one, it's not that easy maybe. So because what would you want to prove that is so I may prove it like that, okay? So there exists a unique integer Q and R. So let's assume that let's assume there is another set of Q and R. I label Q prime and R prime, which also satisfy this equation. And also with this assumption, okay? With at the moment, what you can do is you can see that 0 should be equal to b times q minus q prime plus r minus r prime. And then by definition, by definition, r and r prime is smaller than b and greater than 0. So we assume there is another set of q prime and r prime. That means that they are not. That means that q prime is not equal to q. Let me see. Or r prime not equal to r. Of course, it is or and n, or and. So either both of them are true, or either one of them is true. Then what can we show that? So we can see that r prime minus r equal to b times q minus q prime. So let's say if q equal q prime, obviously what you get is r prime equal r. Okay, this contradicts to our assumption because we assume that there's another set of number. So let's say if r prime equal to r, then you get q equal q prime. This also contradicts our assumption. So what else? If we assume r prime minus r not equal to 0, and q minus q prime not equal to 0, so that means r not equal to r prime and q not equal to q prime. And then how can we prove this one? Now r minus r prime should also be smaller or equal to smaller than b or greater than 0. Then but from this equation, we know that b divides r prime minus r. But r prime minus r is smaller than b. Therefore, b does not divide r prime minus r. Then by proof by contradiction, this statement is true. I understand you haven't learned about the proof by contradiction in your mathematics. But actually, you can see if you can see yourself right for. But you can try to see if you can understand this proof. No? Yes, no?
Okay, so how did you get like 0 equals to b times q minus q prime plus r minus r prime?
Okay, you highlight that equation, okay? I don't know which one do you mean.
Okay, wait, I'm gonna highlight the equation, the one you. How did you get this?
You just use the first equation minus the second equation.
Okay. Okay.
But I think if you consider it as a primary mathematics, I think it's so obvious. I've captured the screen already, okay? Then let's go on to the next concept. Cryptography application. And then we need to learn some terms, greatest common divisor. I think you learned it in primary school already, So we don't need to repeat, okay? So and then another one is two integers a and b are said to be relative prime. So if they are relative prime, if their GCD is equal to 1, so these two are obviously relative prime. So maybe not that obvious. So maybe 14 is 2 times 7. 15 is 3 times 5. They don't have a common divisor other than 1. So by the definition, they are relative prime. Okay. And also, you can see that, okay, nothing. Okay. Then we still have some time, so let's have a look at one trick here. Algorithm means some method to solve some question. The method to solve some question. So if we want to find we want to find the GCD greatest common divisor of these two numbers. It may not be that easy. Because if the numbers are very, very, very large, okay, just like there are several hundred digits, okay, it's very difficult for the computer to find their factors one by one. So we need to use this algorithm to find the GCD. So you may have a look at this algorithm. I think you may try to understand this algorithm. So let's finish today's lesson by talking about this algorithm. So let's assume M to be their GCD, okay? Then right now you should know that so 1, 2, 3 should be some integers times M 4, 5, 6 should be some integer times M also. So how can we find this one? And if 4, 5, 6 minus 1, 2, 3 should also be a multiple of M, okay? So how about 4, 5, 6 minus 1, 2, 3 times 2 should also be a multiple of M. So first of all, we do the division and then find the remainder. So let's say the remainder is 87. Now 87 should also be a multiple of M. Do you understand why? Hello. So how do you get this remainder? You minus the 4, 5, 6, okay, by several times, okay. Let's say there's another integer n, okay. That is the what is it called? This is the quotient, okay. This is the quotient times the am, okay. 1, 2, 3 here. So this is the remainder. Then you can have a look here, okay. This is also a multiple of m. Well, you may think that it's so troublesome, so lengthy to do it like that. Yeah, but if you consider there are several hundred digits, okay, this is already an easy method. So why we do it like that? Because 87, this number is smaller than 1, 2, 3, and 4, 5, 6. If you try to find the remainder, we want to find the GCD, it's easier to compute because this number is smaller. Then what we do next now? 487 that should also be a multiple of m.
Yeah.
So, and then we use the next two smallest number to do it again, using the same trick. So let me clear the screen. So you put the 1, 2, 3 one step forward, okay? And you get the remainder here, 36. Now we write that 1, 2, 3 is A times M, and 87 is C times M. So therefore, 36 is also a multiple of M. So you do several steps until the last one. Until the last one, what does it mean? You can see the remainder is 0. So this is your final answer. 3 is the final answer.
Okay.
And then if you are using the new calculator, okay? In your calculator, can you see there's a symbol just above the ENG? This one. And then there is one we call FACT. That means factorize. So if you press 1, 2, 3, so you press 1, 2, 3, okay? And then equal sign. And then you press this FACT. Then you can see how the calculator help you to factorize this number. It's 3 times 41. Then this 1, 4, 5, 6, you get 2 times 3 times. Now, of course, because this number is smaller, the calculator can find the factors very fast. But if the number is very large, the calculator may take a lot of time to find the factors. Okay. You may have this is the proof, so you may have a look, but so and then so from next time we are going to learn a bit more about the number theorem. So you may have a look at this textbook first, okay? This one is already an easy textbook, I think. If no questions, and then let's have the next lesson on next week. Then bye bye lah.
Bye bye.
Bye bye.